All right, so looks like I'm live as well. Thanks, Marie. That was a wonderful presentation. I think it's a very important thing that you guys are doing. And for those that haven't visited C2MI yet, I encourage you to go and see a really impressive facility that they have. All right, so we are going to be eating into the time for the student presentation. So we'll try to keep it, as time effective as possible. We do have a couple of questions here. We have a question from Marie for Elizabeth. Can we bring Elizabeth in?
I'm here.
So,
Hello.
very good. Okay, we have a question from Marie O'Mahony. The Canadian and German governments have just announced an energy partnership relating to net zero 2050. Hold on. Do you see a potential opportunity for flexible printed electronics in this?
I'm not familiar with that program, I have to admit, because I'm not involved in it. But I think I see, if I would say from this electronic flexible hybrid integration part, I would see a very good chance in Eureka collaboration. I'm not sure if, well, in the bilateral, you can always set up specific projects, and that might also run. Eureka is a returning instrument where you have calls every year on several topics, and there are normally also calls on electronic components and systems integration, and that would also not only include Germany, but also all over Europe, different countries like France, like Italy, Spain, Belgium, the Netherlands, and a lot of countries contributing to this. So I cannot really answer the question of Marie. I would have to look into the program in more detail. Sorry.
Maybe a follow-up meeting between you two.
Yes, we can do.
All right. We have one more question here from Howard Campbell to Marie. What production volumes can C2MI support, and how do you manage the question of potentially competing with commercial suppliers?
So we do not support like high volume production, that's for sure. What we help with is prototyping, and the first lots that somebody, and Diego, you could probably talk about it, is that you probably won't have customers that want to have one wafer lot a year. So you're probably going to take them once they have one wafer lot a month, or maybe depending on the application, maybe more than that. So we kind of help them going through that, what we call the valley of death, where some companies don't have the means to go to higher volume production because they're not, they don't have enough sales yet. So sometimes it can last 6 months, it can last a year. So we're going to help them go through that. But once they're ready and they have a product that can be transferred to high volume manufacturing, we're not in that market. So that's definitely not for us a competition. And I don't think that our partner, that is Teledyne DALSA, that does the high volume manufacture, they don't see us as a competitor as well. So it's really a way to bring a product, a new product, make it more stable, make it more manufacturable for the couple of lots that we're going to do with them. And then when we transfer to high volume, it's easier for the high volume manufacturer to do.
Okay, thanks, Marie. I'm going to reserve one question from me to Tiago. So maybe you can comment on this. As the components or individual size of the individual components and the connector pads and bumps are getting smaller and with smaller pitch, what do you see as the main challenges today from the assembly standpoint, or SMT? Any technologies that really are being tested to the limits, or that are emerging in the SMT area?
I think that's a great question, because especially when we talk about MEMS and sensors, as you can imagine, the structure of those products is very susceptible to mechanical stress. So that's an important aspect when we talk about designs with our hardware design with our customers. So for example, usually there are many hardware guidelines that need to be followed, not only in terms of how the PCB and the materials are being conceived or are being selected by the customer, but also in terms of processes that need to be taken into account. let me give you a simple example. The accelerometer, for example, which is among the simpler ones that you could design. The accelerometer requires that you have a parallel pad implementation. It also requires that you don't have any conformal coating or mechanical stress in your PCB when using this sensor. And this is because any bending or any mechanical stress, as you can imagine, we're measuring nano signals here in the parts. So any mechanical stress or any micro bending that you may have can affect the performance the performances that are expected by our customers. I think that summarizes a little bit of the situation, but of course, we as ST, especially on the microcontroller side, where we have a higher number of pads in the part numbers, we do have several documents and several guidelines to walk our customers through what they should do in terms of processes for assembly.
Mm-hmm. Okay, very good. Thank you so much. All right, so let's see. I don't see any more questions from the audience, and I think we took about 10 minutes from the student poster presentation time. So I think that's not too bad. You know, we've done worse before, I know. Anyway, thank you everyone for your time, for your input, great presentations, and I'm looking forward to the next session. Thank you. Cheers. Bye.
Thank you. Goodbye.